Okay, so we've got ourselves what most people consider to be kind of the holy grail of Algebra 1. We got here the quadratic formula. Uh, so we got x equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? So, it's a little complicated, but, you'll find your way to memorize it. But what's more important, I think, is to know where it comes from. So generally, what I would say where it comes from is it comes from the a use of the completing the square method, which I'm sure you're familiar with on this. So I guess we're going to start it out. So, we have the quadratic equation. We got ax squared plus bx plus c equals 0. So, obviously, what we're going to start out with is our first step is dividing every term by the linear coefficient. The quadratic coefficient that we're going to start out with our a term. So, since we're just not actually solving a real equation, we're just using a generalized form. We're going to do x squared plus b over ax plus c over a equals 0 over a. So obviously that just equals 0, so we simplify it to the aforementioned equation equals 0. So then we can come to, we're going to subtract c over a because that is our constant term, and that's generally what we do. And, obviously we're going to subtract it on both sides. So, x squared plus b over ax equals negative c over a. So now we're going to take the coefficient of the second term. This is where it gets tricky. But this is common in the completing the square method, is b over a, right? So we're going to divide by 2 b over a to get b over 2a, and we're going to square that result. So b over 2a squared. And this is kind of to remedy what we did in the beginning, which wasn't necessarily correct, to divide everything. Well, we could have done it, but this is where the completing the square method becomes slightly more difficult than other methods. So x squared plus b over ax plus b over 2a squared equals negative c over a plus b over 2a squared. So we can factor the left side and square it to get x plus b over 2a squared. And, obviously we're going to square everything because, of the law of square equivalency. And so b squared minus 4ac over 4a squared is going to be the other side. So to get rid of how complicated this all is, we're going to take the radical of both sides. And we're going to simplify the left side first, which is x plus b over 2a equals. And then here we kind of introduce this plus or minus sign. And the reason that's important is because the square root of something can be positive or negative, because negative 2 times negative 2 is 4, just like 2 times 2 is 4. So there could be two possible solutions. And this is where we kind of get into Gauss's fundamental theorem of algebra, which states that the power of equation states its number of solutions. So that's where this comes in. So next we can use our radical laws to get, for the right side, the root b squared minus 4ac over root 4a squared. Since we don't like that radical in the denominator, we're going to simplify that to 2a. So x plus b over 2a is plus or minus radical b squared minus 4ac over 2a. So this is starting to look like our general quadratic formula. So we can subtract b over 2a from both sides, and then x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. So then we're just going to, basically add the numerator and denominator. Well, not add them, but, and we're all set. We have found the Holy Grail. So I thought this was important to kind of show you guys how you come upon this this little equation, in case you were curious, and how it really just stems back to the general quadratic equation. So yeah, I hope y'all enjoyed learning about where this comes from, and hopefully you can better understand what you're doing when you're solving a quadratic equation using the quadratic formula. All right, thanks. This has been really great.